So today we're going to be covering section 6.5 in the textbook. 6.5, the topic is solving rational equations. And as you can imagine, a rational equation is just an equation that contains rational expressions. The examples you see here, they're both the same example. Those are examples of rational equations. The reason why there's two of them is that we have two methods that we're going to show you that you can use to solve rational equations. In the first method, you're going to set up a proportion, and then you're going to solve by cross-multiplying. You need to recall that a proportion is two ratios that are set equivalent to each other. And we have a problem here because on the left side of the equation, we don't have a single ratio. So you need to combine these fractions into a single fraction so that you have an expression that is a proportion to equivalent ratios. All right, so we do that by finding a common denominator. And if with denominators of 5 and 2, my common denominator is going to be 10. So I'm going to multiply this first equation by 2 and get 8x plus, and I need to multiply the second equation by 5. So it's 8x plus 15. And on the right side, we have a single ratio, so we don't need to change anything. Once you have it set up as a proportion, then you're going to solve using cross products. So I'm going to multiply 10 times 8x plus 15, and I'm going to multiply 3x times 10. So 8x plus 15 times 10, distribute the 10, and you get 80x. Well, plus 150 equals 10 times 3x is 30x. Now I can solve the equation, subtract 30, 50x plus 150 equals 0, 50x equals negative 150, which means x equals negative 3. That's the proportion method, and you can use that when you have a ratio set equal to another single ratio. The other way that we can solve this is something called the LCD method, which I also refer to as clearing the fractions. So we're going to find the LCD for all three of the fractions, 5, 2, and 10, all three of the denominators, I should say, and we get an LCD of 10. Once you determine the LCD, then you're going to clear the fractions by multiplying the entire left side of the equation by 10 and the entire right side of the equation by 10. On the left side, you have to distribute that 10 to each of the terms. And I do that by dividing first. So instead of doing 10 times 4x divided by 5, I say 10 divided by 5 gives me 2. And then I multiply that 2 by the 8x, and I'm going to get 2 times the 4x, and I get 8x. For the second fraction, plus, I multiplied 10 times 3 over 2. 10 divided by 2 is 5. 5 times 3 is 15. Equals, and then on the right side, those 10s will just cancel out, and you get 3x. And it looks like we end up with a very similar equation. Solve this, subtract the 3x, subtract the 15, and divide by 5, and you end up with x equals negative 3. So those are the two methods that you can use to solve rational equations. Let's look at a couple more examples. Okay, moving on to the next example, we can see that this problem is a little bit different than the first problem because there are variables in the denominator. And as soon as I see variables in the denominator, I need to recall from the beginning of the chapter that we need to think about domain restrictions. So the first thing you do in a rational equation that has a variable in the denominator is determine what the domain restrictions are. So let's look at our domain restrictions here. Looking at our denominators, we know that the denominator cannot equal 0. So my restriction, or my domain restrictions, would say that x minus 2 cannot equal 0, which means that x cannot equal 2. So my domain restriction is x cannot equal 2. What that means is that if you solve this algebraically and you end up with a solution of x equals 2, then you must eliminate that solution from your solution set because x equals 2 is not in the domain of this function as written. In other words, if you were to plug in x equals 2, you would get 0 in the denominator, which is impossible. All right, so let's go back to solving this. When we solve this equation, since it's already set up as a proportion, let's go right ahead and use the cross products method for solving our proportion. We're going to get x plus 6 times x minus 2 equals 2x plus 2 times x minus 2. Distribute x squared plus 4x minus 12 on the left is equal to 2 times, and I'm going to combine these together to get a difference of squares, since I can see that they're conjugates. Distribute that 2 on the right. And then set the left side equal to 0 so that I can solve the quadratic. 2x squared minus x squared gives me x squared minus 4x. And then I add the 12 to the minus 8 and I get plus 4. Factoring, I see this is a perfect square trinomial that will factor to x minus 2 squared. And then solving that, taking the square root of both sides, I get x minus 2 equals 0, or x equals 2. Now, I have to check back with my domain restrictions. And since x cannot equal 2, I have to eliminate the solution from my solution set, which means I'm left with no solution. And that's the answer to this problem. Okay, moving on to example 3. All right, here I don't have a proportion, so I'm going to use the LCD method to solve that. But don't forget, I have variables in the denominator, so I need to find my domain restrictions first. All right, I've got x in the denominator and I've got 3x in the denominator. Both of those tell me that x cannot equal 0. So there's my domain restriction. Once I have determined my domain restrictions, then I'm going to find an LCD here so that I can clear the fractions. Looking at my denominators, I've got x, 3x, and 3, so my LCD is 3x. And then recall that the second method we learned is I multiply both sides of the equation by the LCD in order to clear those fractions. When I distribute that 3x on the left side, in the first fraction I can see that the x's are going to cancel out, so I get 3 times 3, which is 9, minus, and then when I multiply 3x times the second fraction, the whole denominator will cancel out with the 3x. And I'm going to put this in parentheses so that I don't forget to distribute that negative, equals, and then on the right side, the 3's will cancel out, but you still have to multiply 5 times x. Simplifying, I get 9 minus x minus 21 equals 5x. 9 minus 21 is 12. Negative 12 minus x equals 5x. Negative 12 equals, add the x to the other side, 6x, and then divide by 6, x equals negative 2. That's not one of my domain restrictions, so I can keep that as an answer. In the next example, again, don't forget the first thing you need to do is find domain restrictions. The 2x minus 1 tells me that x cannot equal 1/2. If you're not sure of that, just solve that equation. 2x minus 1 cannot equal 0. But you should be able to do that in your head. And x cannot equal 0. This is not equal. So there's my domain restrictions. And next thing I'm going to do is solve this. And since it's not set up as a proportion, I'm going to use the LCD method. My LCD will be x times 2x minus 1. And I'm going to multiply that times both sides of the equation. In the first fraction, when I distribute, the 2x minus 1 will cancel. So I'm going to be left with x times 2x gives me 2x squared. And then in the second fraction, the x's cancel. So I'm going to be left with 1 times 2x minus 1 equals, on the right side, the 2x minus 1's cancel. 1 times x is x. Simplifying, 2x squared plus 2x minus 1 equals x. Set equal to 0 by subtracting an x. So 2x squared plus x minus 1 equals 0. Factor and solve. 2x minus 1, x plus 1 equals 0. Here I get x equals 1/2 or x equals -1. Compare this to your domain restrictions. I see that x cannot equal 1/2, so I must eliminate that solution, and I'm left with the only solution of x equals -1. And for my last example here, I need to add one additional step to this one. I need to factor my denominators first before I can find my domain restrictions. So I get 2x over x minus 3 plus 6 minus 2x over x plus 3x minus 3 equals x over x plus 3. So for my domain restrictions, I've got an x minus 3 factor and an x plus 3 factor in the denominator, which tells me that x cannot equal 3 and x cannot equal -3. These are my restrictions. All right, so let's use the LCD method to clear the fractions. So my LCD for all three of those fractions is x minus 3 times x plus 3. I'm going to multiply both sides of the fraction by that. Distribute on the left side to both terms. In the first term, the x minus 3's cancel. So you're left with x minus 3 times 2x. Or sorry, x plus 3 times 2x plus, and in the second fraction, both terms cancel out of the denominator, and you get 6 minus 2x. On the right side, the x plus 3 cancels, so you're left with x times x minus 3. Simplify. X plus 3 times 2x is 2x squared plus 6x plus 6 minus 2x equals, distribute the x squared minus 3x. All right, simplify this left side. 2x squared plus 4x plus 6 equals x squared minus 3x. Set equal to 0, so I'm going to subtract x squared. I'm going to add 3x, and then I'm going to factor and solve. Neither of these solutions are in my domain restrictions, so they are both possible solutions. That's it for today. Have a good one.